So this now is a review session. It's not going to be very long because I'm just recording only when people ask questions and I answer them. But the question on the table is as follows. It is the 5 boys in a Cub Scout pack have these heights. Which height has the largest deviation from the mean? What is that deviation? And as a follow-up, compute the mean absolute deviation, the MAD. Well, before you can do anything, you have to compute the mean itself. You can't figure out which height has the largest deviation from the mean without actually computing the mean. So when I add these 3, 4, 5, 6, 7, 8, 9, 10 numbers together, 47 plus 53 is 100, 146, 194, 240, 288, 399, 500. So the total is 500, which means that if I did the math correctly, and on a test, I wouldn't do it very quickly or in my head like that. But if the mean isn't, I think the mean is 50. I seem to recall that being the mean. So which height has the largest deviation from the mean? Well, this is 3 away. This is 3 away. This is 4 away. This is 2 away. This is 4 away. This is 2 away. This is 5 away. This is 6 away. This is 1 away, and this is 0 away. So the largest deviation from the mean would be 56 inches. And what is that deviation? That deviation is 6. Okay, the deviation is the observed value minus the mean. 56 minus 50, so the deviation is 6. Now it says compute the mean absolute deviation. So to that end, we have to compute each deviation. I get 3. Well, if I ignore the negative signs, because I'm going to take the absolute value anyways. 3, 3, 4, 2, 4, 2, 5, 6, 1, 0. Those are the absolute values of the deviations. So the MAD, the mean absolute deviation, is what I get when I add those numbers and divide by the number of numbers, which is 10. 3, 6, 10, 12, 16, 18, 19, 25, 30 over 10. So the mean absolute deviation is 3. The mean absolute deviation is 3. And the question says, thank you. No, sorry. Thank you, sir. I don't know why the sir wasn't part of the exclamation parts. That seems very inappropriate, but whatever. Seems like,
I think I'll be more ready for questions when I can see the answers because I don't know which ones I got wrong.
I understand. All right, 6A, Hasmik is asking. So Alaska prints 2 million lottery cards. 2 of the cards pay the buyer 1 million. 10 of the cards pay the buyer 10,000. What is the fair price for 1 lottery card? Well, the probability of winning $1 million is 2 over 2 million, because 2 of the 2 million cards have $1 million reward. So the probability of winning $1 million times the amount that you win, which is actually $1 million, plus the probability of winning 10,000. Well, 10 of the 2 million cards have 10,000. So the probability of winning 10,000 is 10 over 2 million times the amount, which is itself 10,000. So this is the payoff. And this should be equal to the amount. Well, let's do it like this. These are the payoffs, right? You can get $1 million payoff, and there's a 2 in 2 million chance of that happening. There's a $10,000 payoff, which is a 10 in 2 million. So when you do these numbers, the total payoff, or the total expected amount of payoff, 2 times 1 million over 2 million is just, of course, 1. And then 20,000 divided by 2 million is 0.01. So the expected amount of a payoff is 1.01. That is the expected amount per person. You should expect each person on average of the 2 million people to get $1.01. Well, if this is a fair lottery, then that means that those $2 million, that those 2 million people should each pay $1.01. So that the $1.01 per person that is paid to them is balanced by the $1.01 that each person pays. So a fair price would then be $1.01. Another way of seeing this is if each of the 2 million cards cost $1.01, that would be a total pay of 2,020,000. Sorry, 2 million. Sorry, did I do that correctly? Sorry, I did my math wrong. Nobody caught it. I did bad math. This is not 20,000 over 2 million. It is 10 times 10. Let's rewrite this. I did bad math. I apologize. It's 10 times 10,000, not 2 times 10,000. So it's 10 times 10,000 divided by 2 million. That's not 1.01. That's 1.05. So the expected payoff is $1.05 per person, and therefore the expected amount paid in is $1.05 per person. Let's just confirm. If we take the 2 million people, each times $1.05, that is in fact $2,100,000. 2 million to those two, $100,000 to those 10. 1 million, a million, 10, 10, 10, 10, and so on. That's a fair price. Now, if Alaska charges $2 per lottery card, how much money will it make? Well, it's only making 95 cents per card because $1.05 of the card goes to pay out the prizes. So it's making 95 cents per card, but it's also selling 2 million cards. So the answer is nothing more than 2 million times 95 cents, which is a total of $1,900,000. Right? The profit is 95 cents per card, 2 million cards. That comes out to being $1,900,000. Does that make sense, Hasmik? You're welcome. I'm going to stop recording until another question is asked. So now 7 has been asked. Yes, I need to find something funny. All right, number 7. The Wechsler Intelligence Scale for Children, the WISC-4, much better than the first 3, is a TACU test used by the LAUSD. This test is normally distributed with a mean of 100 and a standard deviation of 15. What is the IQ score of a student who scores 1.4 standard deviations below the mean? Well, if they score 1.4 standard deviations below the mean, that means their z-score is negative 1.4. And the formula for z-score is data point, which is what we're looking for, minus the mean, divided by the standard deviation, which is 15. So negative 1.4, which is my z-score, is equal to x minus 100 over 15. So how do I solve this mathematically? How do I solve this mathematically?
Multiply by 15.
Multiply both sides by 15. I get negative 21 is equal to x minus 100. And therefore, what is x?
Negative 21 minus 100, negative 20, negative 121.
No. How do you get x by itself here?
Oh, add 100.
Add 100. What's negative
Sorry.
21 plus 100?
79.
Wrong math.
79. Now, Lisa Simpson has an IQ of 146. She is reasonably intelligent. What is her percentile? What is her percentile? So if I look at my normal distribution, the center is 100. And the standard deviation is 15. So that's 115. That's 130. That's 145. So she lands right here past 145. That's more than 3 deviations up. That's pretty intelligent. So what is her percentile? Well, the first thing we got to do is go from data to our z-score. You don't go directly from data to percentile. You go data to z-score. 146 minus 100 over 15. This gives us a z-score of 3 and 1 over 15, which as a decimal is 3.06 bar. So then I go to my calculator or to a computer
Pregunta.
calculator. Huh?
Can you round it to like 3.7?
Yeah, but if you're going to use a calculator, then why not use as many decimal points as possible for maximum accuracy?
Gotcha.
So we want to see how much is less than 3.066666, where the mean is 100, and where the mean is 0 and sigma is 1, and the answer is her percentile is the 99.9. That's pretty high. A 99.9 percentile. This is a calculator calculation. You do not do this by hands. Then it says, write a short note to Lisa's father interpreting the result of her IQ test so that he can understand it. Lisa, Mr. Simpson, scored higher than 99.9% of those who took this test. She is rather intelligent, much smarter than Bart, and certainly much smarter than you. Now, Lisa's little sister Maggie took a different intelligence test and got a T-score of 62. Who scored higher relative to other students, Lisa or Maggie? Well, if you're going to compare them, we have to actually have both of their T-scores or both of their Z-scores. So let's do the T-score for Lisa. What is Lisa's T-score? So what's the formula to compute a T-score?
10 times the z-score plus 50.
10 times the z-score plus 50. So if I take Lisa's score, which is 3.06 bar times 10, and then I add 50 to that, I get what? 83. What is it? 3.066666 times 10 plus 50. 80.66666. Her T-score is 80.6 bar compared to Lisa's, compared to Maggie, who is 62. Oh yeah. And therefore, because Lisa's T-score is higher than Maggie's T-score, Lisa did better relative to those who took her test than Maggie did relative to those who took her test. Another way of doing it would be to compute Maggie's z-score and compare their z-scores. Another way to do it would be to compute both of their percentiles and compare their percentiles. Any one of these would have given the correct answer, but I believe this is the easiest way. And that concludes question number 7. I will pause recording.